Welcome to Chemistry 1B's second example where we work with specific heat now. The problem is such that we are asked to calculate how much heat energy must be lost from a 250 ml cup of coffee for the temperature to fall from 65 degrees to 37 degrees. Okay, we're also given the density and we're given the specific heat capacity of coffee, which is equated to the specific heat capacity of water. This is a fairly straightforward problem. Okay, so we have the 250 mils can be calculated to be 250 grams, which is done in a later step. I'll show you now. And of course, we have the equation that we need to use, which is Q is equal to specific heat capacity times mass times temperature change. The temperature change can be calculated fairly easily. Again, it's a temperature loss, you can see, or a drop from 65 to 37. So that would imply that the temperature change is going to be negative, which indeed it is. If you work it out, you can see over here. We can then plug in the values that we need. So we've got the specific heat as 4.18 and then multiply by the mass. Remember, the mass can be found from the density times volume, okay? So, which is what I've worked out over here already for you. So it's 250 moles times by 1 and then multiply by the temperature change. And we see that Q ends up being minus 29.3 times 10 to the power 3 joules, and they convert directly to kilojoules for the final answer of 29.3 kilojoules. So that is the amount of heat energy that is lost when coffee cools from 65 degrees to 37 degrees.